Okay, so let's look at graphing rational functions. So I'm going to go through this first page just to touch base on some things about a rational function. So the first thing is a rational function is in the form f of x equals p of x over q of x. Okay, so basically what I'm saying is p of x and q of x are just polynomial functions. And of course, q of x can equal 0. Okay, one of the simplest forms is the reciprocal, and that is just 1 over x. And of course, that is shown over here. So let's start talking about the different parts that we're going to see with a rational function. So the first one is an isotope. So basically, this is a line which the graph approaches. So if you look over here on this one, I'm going to zoom in, okay? You can see that right here, the graph gets close to it, but it does not touch it. So that's 1, 2, 3, so it's a -3. So we have a vertical isotope of a -3. And then if you look close, again, right here, we have another line that the graph gets close to, and we do not touch it. And that one is going to be our horizontal isotope, y equals 1. Okay, so I'm going to zoom back out. So that's what vertical and horizontal isotopes are. And of course, I will help you find them in just a second. So the next thing is a hole. So a hole is like a vertical isotope, but it only happens in that one spot. So the easiest way to look at it is you want to find a common factor. So what ends up happening, sorry, these are your common factors. So, and the reason why is x minus 2, if I set that equal to 0, I get 2. Well, if I plug in a 2 right here, then the whole entire problem is undefined because 2 minus 2 is 0, and then 1 times 0 is 0, so I'm dividing by 0, which we can't do. So this is where the hole comes into play when we have a common factor. So if you notice, I'm left with f of x equals 1 over x minus 1. So to figure out where my hole is at, then I just plug in my value. So that would reduce down to 1. So I have a hole at 2, 1. And if you see, it is right there on our graph. Okay, and that is how we find our holes. So probably one of the biggest things about graphing rational functions is making sure that you know what to do to find all the parts. So the most important one is putting it in factored form. We have to do that because that allows us to find our holes. So typically factored form is like the first thing that I do, and then number 6 is the next thing I do because I want to take care of my hole. Then after that, I just do my x-intercepts. So remember, when you want an x-intercept, y is 0. When you want a y-intercept, x is 0. Vertical isotopes come from the q of x. So remember that the q of x is in the bottom. So you are looking at the denominator. So let's write that as, we'll go this way. What makes the denominator equal to 0? Because remember, if we found a hole, then our hole is technically already gone. So we don't have to worry about that. So the next thing is going to be our horizontal isotopes. So these are the ones that you're going to have to make sure you remember. If the numerator, because that's the degree of p, is greater than the denominator, there is no horizontal isotope. okay? But if the numerator is smaller on the top, the degree on the top, then we will have the x-axis, which is y equals 0, because we're comparing the degree. So if the degree on top is bigger than the bottom, then there's no horizontal isotope. Because when this happens, it opens up a slant or oblique isotope. Okay, and we'll talk about that here after a while. Now, if they're equal to each other, so if the degree on top is equal to the degree on the bottom, then it is the leading coefficient of P of x over the leading coefficient of Q of x. So basically, it's the leading coefficient of the top over the leading coefficient of the bottom. Okay? So we're going to use some of these steps and then just try to work out a basic problem. Okay, so here we go. Let me see if I can find one where we have to factor. I think example 2 factors. Yep, let's do that one because I want to try to put more in it if I can. Okay, so like I said, the first step we got to do is factor. So we need to factor to the top and factor to the bottom. So the top is going to change to x minus 1, x minus 2 over x plus 3, x minus 2. So notice we have some common factors. So I am going to cross those out. That means I am going to have, I'm going to zoom out. So I'm going to try to get it all on one page. There we go. So I'm going to zoom out. That means I have a hole at 2 something because, of course, 2 is what would make that 0. So I have x minus 1 left, x plus 3. So let's just go plug that in. So 2 minus 1 over 2 plus 3. That means my y value is 1/5. So I just want to go to 2, and then right above that, I am going to have basically a 0. Okay. The next thing, let's do our x and y intercept. So if I want the y intercept, I just got to plug in 0. So 0 minus 1 over 0 plus 3. So negative 1/3. So my y intercept is 0, negative 1/3. So I'm going to have a y-intercept about right there. Now let's do our x-intercept. X-intercept is when you set the problem equal to 0. So now y is equal to 0. We have x minus 1 over x plus 3. Well, if I multiply both sides by x plus 3, then this is still just 0. So if you want a shortcut, it's actually just setting the numerator equal to 0 when you need the x-intercept. So that means my x-intercept is going to be 1, 0, because x equals 1. Okay. Let's go to our vertical. Our vertical isotope is what makes the denominator 0. So here's the denominator. X plus 3 equals 0. So x equals a negative 3. So 1, 2, 3. Okay. Vertical isotope comes from those rules. So remember, you need the degree on top and the degree on bottom. So the highest exponent, which is the degree, is 1. Bottom, the highest exponent, is 1. So remember, that's when you divide leading coefficients, and these are both understood to be 1. So y equals 1. Okay, so for the most part, we have actually done all of the work. So we just need to plug some values in. So if we plug in a negative 2, we'll get a negative 3. So we can make the bottom of this graph go this way. Remember, don't go through your hole. You'll get close to it, but not touch it. We have negative 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. We got negative 7, 2. 1, 2, 3, 4, 5, 6, 7, 1, 2. And we can just kind of curve those together. We got our graph going this way, and we got our graph going this way. Okay. So the only thing that would be left would be our domain and range. So if you notice the x's, I use everything except for my vertical isotope in my hole. So that means I have negative infinity to negative 3, negative 3 to 2, and 2 to infinity. Okay, now on the y values, I use everything except for, so I want to double check my hole. So if I double check my hole, it's kind of like I'm looking over here. Nothing over here is using that. So it's my hole and my horizontal isotope. So it's negative infinity to 1/5, 1/5 to 1, and then 1 on to infinity. And so that is how we would do this one. Now, the question was, I also made a comment about, I guess it's all on this one. We will be seeing slant isotopes. So slant isotopes come from dividing, but it's only when something in particular happens. So the only time you can have a slant is if this happens. So when the degree of p of x, which is on the top, is exactly 1 more than the degree of q of x, which is the bottom, you have a slant. And remember, if there is a if the top is bigger than the bottom, you have no horizontal. So therefore, that's what opens up an oblique. But an oblique has to only be 1 more bigger than it. So let's look at let's look at this one. X cubed. Oh, that's a small one. Okay, I guess I don't have my bigger one, so we're just going to have to use this one. Okay, so the first thing you want to do, of course, is to factor it. That is not going to change. So let's take out an x. And then let's factor that. So that's going to be x over x plus 4, x minus 1. If you look at the bottom, that looks like x plus 2, x minus 1. So if you notice, I went ahead and gave us another whole one. So I'm going to cross this out, and I'm going to have a hole. And this is one of my old ones, so I'm missing slant isotope right there. Okay, so now we're left with x plus 4 over x plus 2. So let's go plug in 1. So to actually do that, I think I'm going to go ahead and distribute. Nah, it's fine. I'm going to plug it in up here though. 1 plus 4 over 1 plus 2. So that looks like that will be 5 over 3. So the first thing I want to do is go get that on here. So 1, and then right there. Okay, so now let's go find some other things. If I were to plug in zeros, so 0, 0 plus 4 over 0 plus 2, that would reduce down to what? 0. You got it. So your y-intercept is 0. Okay, now let's set it equal to 0. So x plus 4 over x plus 2. So remember in the last one, when I end up multiplying x plus 2 to both sides, those end up canceling. And of course, this is still, well, I guess I shouldn't say that one cancels. It's going to still be 0. So 0 equals x plus 4. So x equals 0, x plus 4 equals 0. So x equals -4. So I actually have 2 x-intercepts. Okay. Vertical comes from the bottom, so there it is. That will be x equals -2. Oops, I didn't go put my other x-intercept on there. 1, 2, 3, 4. There we go. Being -2, so we have a line right here. Okay. Now, if I was to redistribute this, this would be an x squared plus 4. So the degree on top is 2. The degree on bottom is 1. So that is exactly 1 higher. So I will have a slant, but I will not have a horizontal. Okay. So to find the slant, we want to go divide our problem. So let's go do synthetic division. So -2 goes in the box. We have an x squared coefficient of 1. I'm missing my x, and then I have a 4. So 1 times -2 is a -2. Add, it's -2, -2 is 4, and this is 8. So what we do is we ignore the remainder. So my slant is y equals x. Sorry, my brain stopped for a second because I knew something was off. I forgot to put my x here. So we need to relook at this. So it'll be 1, 4, and then 0. Because I was like, hold up, something's wrong. So this would be a -2, which gives me a 2, which gives me a -4, and then a -4. So we ignore that. So it's +2. Because I knew something was about to be wrong. So remember, and I might have forgot to mention it, but it's when you're finding the oblique, you ignore the remainder. So it will be a linear line because it's a slant one. And so now I'm going to go graph that. So I go 1, 2, and then a slope of 1. Okay. But from here, we can really just try to start graphing. So you always want to make sure you make some type of table. So one ordered pair I need is like -1. So if I plug -1 into whichever problem that you want, you can use the multiplied out one. You can use the factored one. Either one's fine. But a -1 is going to give you a -3. So as you can see, this graph is going to go this way, and it's going to go closer this way. So that's -1, -2. Let's plug in -3. So if you plug -3 into that, we're going to get a 3. So as you can see, this one's going to curve this way, and then it's going to curve this way. If we look at the domain, that's what x's are not being used. So if we look, we're not using our vertical at a -2, and we're not using our whole. So therefore, we have those two to take into consideration. So that will be -infinity to the -2, and then the -2 to the 1, and then the 1 to infinity. But your range is slightly different. Okay, so when you're looking at your range, you are going up and down. Now with these slants, you just have to be careful. So if you look, I'm not using my y value of a whole right here, but I am over here. So it is actually all real numbers, because I am actually using everything. So I hope this helps.